Welcome everyone. In this walkthrough, we'll look at an exam question involving oxidation states. It's taken from an A-level Chemistry past paper, details are in the description. You will have to apply your knowledge of oxidation states from year 1 to a complex ion. Complex ions are not studied until year 2, and this particular complex is not one that you're likely to be familiar with. Let's get started. Here's the question. Give the oxidation state of vanadium in VO H2O5 2+. The concept of oxidation state provides chemists with a method to take a detailed look at the location of bonding electrons within substances. We imagine that every bond between two different types of atom is ionic. Oxidation state is equal to the charge on each ion. The location of electrons in a chemical bond is related to electronegativity. We use rules and guides for assigning oxidation states that are linked to the concept of electronegativity. In this case, combined means bonded to a different type of atom. Combined hydrogen usually has an oxidation state of +1. Combined oxygen usually has an oxidation state of -2, and the sum of the oxidation states is equal to the overall charge on the compound or ion in question. There are other rules and guides for assigning oxidation states, but these are the only ones that we need in order to address this question. It's important not to confuse oxidation state with charge. I'll show you what this means as we work through the question. The total charge on this complex ion is 2+. First, let's look at hydrogen. Combined hydrogen has an oxidation state of +1. There are 10 hydrogen atoms present in this complex. The sum of the oxidation states of the hydrogen atoms is +10. Next, let's look at oxygen. Combined oxygen has an oxidation state of -2. There are 6 oxygen atoms present in this complex. The sum of the oxidation states of the oxygen atoms is -12. Finally, to work out the oxidation state of vanadium, we use the rule the sum of the oxidation states is equal to the overall charge on the compound or ion. I have worked out the answer using algebra. X represents the oxidation state of vanadium here. Strictly speaking, the sign, plus or minus, goes first when referring to oxidation states. The oxidation state of vanadium is +4. When referring to the charge on an ion, the number comes first. So this complex ion, for example, has a charge of 2+. There is a quicker way to work out the oxidation state of vanadium in this compound. Each water molecule has an overall charge of 0, so we can ignore the oxidation states of the atoms in the water ligands. The 2+ charge on the complex ion is the sum of the oxidation states of the vanadium and the oxygen atom that is not part of a water ligand. Thanks for watching. I hope you found the video useful. Post in the comments if you have any questions or suggestions. Take care and good luck with your studies.